Temperature measurement interview questions and answers. 1. What are the different methods of temperature measurement? There are two main methods. 1. Mechanical method. 2. Electrical method. 2. What are the common mechanical methods of temperature measurement? Common methods include mercury glass thermometer, bimetallic thermometer, pressure spring thermometer. 3. How does a mercury glass thermometer work? It consists of a glass tube with a mercury reservoir. When temperature increases, the mercury expands and rises inside the tube. The level is read against a calibrated scale. 4. What is a bimetallic thermometer? A bimetallic thermometer consists of two different metals with different expansion rates bonded together. When temperature changes, the metals expand differently, causing the strip to bend and indicate temperature. 5. What are the types of pressure spring thermometers? There are 4 common types: liquid-filled, vapor pressure, gas-filled, mercury-filled. 6. How does a liquid-filled thermometer work? When the bulb is exposed to temperature, the liquid expands. This expansion creates pressure that operates the pressure spring and moves the indicating mechanism. 7. What is a compensated thermometer system? A compensated thermometer system minimizes the effect of ambient temperature changes on the measurement, so the indication mainly responds to the process temperature. 8. How does a gas-filled thermometer work? A gas-filled thermometer works on the principle that gas pressure increases as temperature increases at constant volume. Nitrogen is commonly used as the filling gas. 9. How does a vapor pressure thermometer work? It uses the vapor pressure of a liquid inside the system. As temperature changes, the vapor pressure changes and operates the indicating mechanism. 10. What is a thermocouple? A thermocouple is a temperature sensor made from two dissimilar metals joined together. It works on the Seebeck effect and produces a small voltage related to the temperature difference between the measuring and reference junctions. 11. What are the hot and reference junctions of a thermocouple? The hot junction is the measuring junction exposed to the process temperature. The reference junction is maintained or compensated at a known reference temperature. 12. What are the common types of thermocouples? The common types of thermocouples are Type J, iron and constantan. Type K, chromyl and alumyl. Type E, chromyl and constantan. Type T, copper and constantan. Type R, platinum and platinum rhodium. Type S, platinum and platinum rhodium. 13. What is an RTD? RTD stands for Resistance Temperature Detector. It measures temperature by detecting the change in electrical resistance of the sensing element. 14. What is the working principle of an RTD? The resistance of the sensing element increases as temperature increases for a positive temperature coefficient material. 15. What materials are commonly used for RTDs? Common materials include platinum, nickel. Platinum is widely used because of its good accuracy and stability. 16. What does PT100 mean? PT100 means a platinum RTD having a resistance of 100 ohms at 0 degrees Celsius. 17. What is the resistance of a PT100 at 100 degrees Celsius? For a standard PT100 RTD, with a temperature coefficient of approximately 0.00385 ohms per ohm per degree Celsius, the resistance at 100 degrees Celsius is approximately 138.5 ohms. 18. What is a two-wire RTD system? A two-wire RTD uses two wires to connect the RTD to the measuring instrument. It is generally suitable for short-distance applications because lead wire resistance can introduce measurement error. 19. What is a 3-wire RTD system? A 3-wire RTD uses an additional wire to compensate for lead wire resistance. It is commonly used for longer distance connections. 20. Why is a 3-wire RTD preferred over a 2-wire RTD? The 3-wire arrangement provides better compensation for connecting wire resistance, resulting in more accurate temperature measurement. 21. What is a potentiometer temperature measuring circuit? A potentiometer circuit compares the unknown thermocouple voltage with a known reference voltage. The difference is used to operate a balancing mechanism until the two voltages are equal. 22. What is the burnout feature in a temperature recorder? The burnout feature provides an indication when the input circuit becomes open, such as when a thermocouple breaks. The recorder drives the indication toward a predefined end of the scale. 23. What is upscale burnout? In an upscale burnout arrangement, an open input circuit causes the recorder indication to move toward the upper end of the scale. 24. What is downscale burnout? In a downscale burnout arrangement, an open input circuit causes the recorder indication to move toward the lower end of the scale. 25. Why is a converter used in a temperature recorder? The converter converts the DC input signal into a proportional AC signal suitable for the subsequent amplifier and balancing circuit. 26. Why are thermowells used? A thermowell protects the temperature sensor from high pressure, corrosion, erosion, abrasion, physical damage. It also allows the sensor to be removed for maintenance without directly exposing it to the process when properly designed. 27. What factors should be considered when selecting a thermowell? Important factors include corrosion resistance, oxidation resistance, mechanical strength, thermal conductivity, resistance to mechanical and thermal shock, resistance to gas leakage. 28. What materials are commonly used for thermowells? Common materials include stainless steel, inconel, monel, alloy steel, alloy C. The final material depends on the process conditions and project specifications. 29. How do you calibrate a temperature recorder using a potentiometer? Connect the potentiometer output to the recorder input with the correct polarity. Set the appropriate reference or ambient compensation. Apply the required thermocouple millivolt values and adjust the recorder at the required calibration points. 30. What should be considered when calibrating a thermocouple recorder without automatic reference junction compensation? Measure the actual reference junction or ambient temperature and determine the corresponding thermocouple millivolt value. This value must be considered when applying the calibration signal. 31. What sensing element can be used for very low temperature measurement? An RTD, resistance temperature detector, can be used for accurate low temperature measurement depending on the required temperature range and application. 32. What is a skin temperature thermocouple? A skin thermocouple is installed directly on the surface of process equipment or piping without a conventional thermowell. It is commonly used for measuring surface temperature. 33. What is special about thermocouple extension or lead wires? The correct thermocouple extension or compensating wire must be selected to match the thermocouple type and maintain the correct thermoelectric characteristics up to the reference junction. 34. What is the difference between a potentiometer and a Wheatstone bridge? A potentiometer measures voltage by comparing an unknown voltage with a known reference voltage. A Wheatstone bridge measures changes in resistance by detecting the imbalance between the bridge arms. 35. What is reference junction compensation? Reference junction compensation is used with thermocouples to compensate for changes in the temperature of the reference junction. 36. How is automatic reference junction compensation achieved? A temperature-sensitive resistor, such as a nickel resistor, is located near the reference junction. As the reference junction temperature changes, the resistor changes its resistance and provides the required compensation. Thanks for watching. Please subscribe, like, share, comment. IIQA